Okay, let's go through some examples for solving the area. And first of all, if it's possible, just do some kind of sketch about the graphs. Here we see the first y is parabola downward because there is minus x squared. So we have some kind of parabola downward. The second is minus x plus 2. Once again, minus 1 as a multiplier. It means that it has to be line going downward. So it's something like this. And we want to have the area restricted by this. So the area we are concerned is this one. So what we need to solve actually is this intersection point and this intersection point. Because when we know from where to where, we have to solve the area. So that's why first here is solved the intersection points. Involves, of course, both y's equals. So we just put the expressions to be equal. So after simplifying, we see it's normal quadratic equation, which we can solve. And we get two values for x. Either x is 2 or x is 5. So what we know at this point is that this one is at 2 at the x-axis and this is at 5. Here it is also solve the values of y for both of them, but actually those are not needed. What we need next is that from 2 to 5, parabola is above the line. So when we solve the actual area, it has to be parabola minus the line from starting point to the end point. So parabola minus the line, please remember use the brackets, and from starting point 2 to 5. Simplify, integrate, and then substitute first 5 here minus, when you use the 2 here, you get the result. This was our sketch. This is accurate graph. This one is not needed because for us it's more important. We see how the graphs are going there, some kind of idea. So what we know which one is above and which one is below. In the next example, let us define the area between minus x cubed minus 2x squared plus x plus 2 and the x-axis. Once again, we have minus x cubed. There is minus, so it's going downward. 1, 2, 3. We don't know whether the x-axis is here, here, or here. So that's why we solve the zeros of this expression. We find 3 of them, so we already know that the line must be somewhere here. If it's here, there's only 2 points. If it's here, there's only 2 points. Here or here, only 1. So now we want to get the area here and here. We already have all the zeros, so we know this is minus 2, this is minus 1, and this is 1. This one is our function. So from minus 2 to minus 1, function is going below the x-axis. So we have to put the minus sign before. here function is going above the x-axis, so we can use the actual function. And we have to do the integral in parts. So here we have a minus sign because it was below the x-axis. Here we don't need it. So it's this area plus this area. Function integrated. Substitute the lower and upper value in both of them, and you get the result.